we were discussing the fundamental of electronics, the diode circuits, and we have covered in the previous lecture the clipper circuits. In this lecture, we will focus on clampers. First, we will see what are positive clamper circuits, and then we will move to the negative clamper circuits. Let us first see what is the difference between the clampers and clamp. So this we have discussed in the previous lecture regarding the limiters and the limit clamp. Clamper adds a DC voltage to the signal. So whenever we require to add certain DC voltage to an existing input signal, then that is known as clamper circuit. Whereas clamp circuit, it will protect any type of sensitive circuit by limiting the voltage. When sensitive circuits are there and it requires to avoid the pass of any high voltage, then in that case, it will limit the voltage and it is known as clamp. What are positive clamper? So positive clamper operation will shift the AC reference level up to the DC level. So here we have the positive clamper. We are giving AC signal of maximum amplitude plus Vp, and negative we have minus Vp. Then if we want to shift the AC reference voltage up to the DC level, like using the positive clamper, we can think that we are adding a DC voltage of plus Vp. So the voltage that we get at the output is basically twice the maximum voltage what we have applied in the input side. So AC signal is centered on the positive DC level. It means that you are basically crossing the zero level and you are getting the maximum voltage as twice the input level voltage. What are the effects? Each point on the sine wave is shifted upward. So we are basically shifting the sine wave upward, and the positive peak is twice the input peak. Negative peak has to be 0 volt. So we require the negative peak here to be 0 volt using the positive clamper circuit. Let us see the working principle of these positive clamper circuit. So we will have a capacitor which is initially uncharged. So there is a capacitor which is connected in series with the source. And on the first negative half cycle, so here with a diode is connected which is reversed biased, and this will conduct only in the negative half cycle. The diode will conduct and the capacitor will charge to a potential of plus Vp, which is at the input side. So the clamper should have the time constant, which is the product of IC, should be greater than 100 times the time constant of the input signal to ensure that capacitor remains charged. It acts like a battery of having the voltage Vp, and it produces a positively clamped signal. So you can see that at the output, it will shift the voltage upward from the zero level, and you will get the maximum voltage as plus 2 Vp. So the diode will act as a closed switch in the reverse bias condition, and it will act as a positive open switch in the forward bias condition. Real world consideration, if we talk about, then you should have a diode drop of 0.7 volt. So instead of having the 0 volt, which is what the ideal condition is, but the practical condition, we will have some negative voltage of 0.7 volt, which is the threshold level of the diode forward voltage drop that you have, and the output reference level will slightly below 0, that is minus 0.7. But the ideal condition should have 0 volt, but we are getting minus 0.7. This is the forward voltage drop, and here the diode is reverse biased, so we have minus 0.7 volt. So next we will see the negative clamper circuit. In the negative clamper circuit, which is opposite to the positive clamper circuit, the diode will be reverse biased. So here the diode is reverse biased during the positive signal operation. So positive clamper, your diode was moving upward. Here the direction of the diode is shifting downward. Capacitor voltage will reverse. So you have a capacitor which is voltage will be reversed, resulting in negative clamping effect. So the input signal, whatever we have given, that is basically AC signal of plus Vp, and the diode is having a direction in the downward direction. So sine wave will be shifting downward. So the net output that we get at the output of the load resistor will be shifting downward, and the maximum amplitude will now be twice the maximum amplitude in the negative direction. So it is minus 2 Vp. It will create a negative clamping, and the clamping level again in the ideal conditions should be 0 volt. But what happens due to the forward voltage drop, the reference level will have plus 0.7 volt in the positive half cycle. So how do we remember the diode orientation? It is a memory aid which acts like a diode. So in the diode will point in the direction of the waveform shifting. For example, if you want to shift the diode downward, then in the diode pointing downward will act as a negative clamper, and diode pointing upward will act when the waveform shifts up. So if we want to shift the waveform down, then the diode will be in the downward direction. If we want to shift the waveform up, then the diode will be in the upward direction. So that acts as a memory aid. If we talk about the application of this clamper circuit, it widely used in television receivers to adjust the video signal reference level, and it is found in radars as well as the communication circuits. There are imperfections, which is because perfect clamping is not obtained because of the diode barrier potential drop. So you have certain barrier potential of the diode which do not help the circuit to get the perfect clamping. So these solutions are there to have the perfect clamping, which will involve the op-amp circuit in the along with the clampers, and this will be discussed in very detail later when we will discuss the perfect clamping in the coming lectures. So in this lecture we have discussed about the clamper, and previous lecture we discussed about the clippers. These two circuits are important when we try to put some DC voltage reference level. Thank you for now. See you in the next lecture.